Hello, my name is Usama Saqib, and I'm a software engineer at Datadog. Today, I will be discussing the issue of re-entrancy in eBPF programs. So, what is re-entrancy? Well, in this context, re-entrancy is defined as the scenario where we have two eBPF programs running concurrently on the same CPU. What signals do we expect to see if re-entrancy occurs? Well, for this presentation, we will be looking at two signals, kprobe misses and interleaved execution. Before discussing how these signals manifest due to re-entrancy, let's take a step back and revise some of the execution guarantees provided by the kernel for eBPF programs. eBPF programs run with preemption disabled. As a quick aside, this is only true until version 5.7, after which eBPF programs use migrate disable instead. Regardless, the core point here is that eBPF programs do not disable interrupts from the processor. The implication of this is that the execution of an eBPF program can be stopped midway. This is the core issue from which other complexities arise. So how do re-entrancy and kprobe misses relate? Before we begin, let's briefly look at how kprobes work. Kprobes work by instrumenting an address with a debug trap. The kernel does not allow nesting of kprobes. If nesting is detected, then the kernel records a miss and moves on. Statistics regarding these misses are exposed via the sysfs through a file called kprobe_profile. So given this, how do kprobe misses happen? Well, one way is if we have a kprobe attached to a function which runs from within an interrupt context. The scenario here is that we have a kprobe triggered from a function which is running in user context. This kprobe is interrupted, and in the interrupt handler routine, another kprobe is triggered. At this point, the kernel will read a per CPU variable holding a reference to the current active kprobe context. If this reference is present, then that means nesting has occurred, and the kernel increments the kprobe missed counter. The handler is entirely skipped by simply single-stepping over the instrumented instruction. I will briefly also mention that there is a second way that kprobe misses can occur, which is not related to re-entrancy. I refer to these as spurious misses because the handler itself is never skipped. The way this happens is when a fault occurs during the execution of a kprobe handler, for example, a page fault due to the use of BPF probe user. The kernel, during the fault handler routine, the kernel increments the nmissed counter. The implication of kprobe misses are application dependent. However, for example, one implication could be map entry leak. This can happen when the lifecycle of map entries is managed across multiple probes. Map entry leak can deteriorate map health over time. Another implication could be to accuracy for tracing applications, since kprobe misses can lead to missed events. Next, we will discuss how interleaved execution can happen due to re-entrancy. For this presentation, we will specifically be looking at interleaved execution of eBPF programs attached to a socket filter. Again, the core issue over here is the fact that interrupts can happen and stop the execution of an eBPF program midway. So as a starting point, let's take a look at, let's revise briefly some features of interrupt handling in the Linux kernel. Broadly speaking, interrupts are handled in three phases. The first two phases are immediate and run with interrupts from the processor disabled. The final phase is deferred and run with interrupts enabled. Soft RIQs are one example of a deferred execution mechanism within the Linux kernel. Soft RIQs again run with interrupts disabled, and they're scheduled after a hard RIQ or from a ksoft RIQ thread. So given this context, how does interleaved execution of socket filters happen? Well, socket filters can execute in both user context and interrupt context. On the transmission path, the socket filter executes in user context, and on the receive path, the socket filter executes in an interrupt context. Therefore, A socket filter, for example, running in NetRx soft RIQ can interrupt a socket filter running in a user context. Since the kernel does not provide any guardrails for nested execution of socket filters, we end up with interleaved execution of two instances of eBPF programs. One implication of this interleaved execution could be corruption of private per CPU data. Thank you. This is all I had to say about eBPF re-entrancy. Thank you for listening.